Good afternoon. Thought I saw some folks in here earlier. Welcome to the stream. We'll get started in just a few minutes. Hope everybody's had a good week. For those of you in the United States, it was a holiday week, so we got the opportunity to, take some time and relax, spend time with family, hopefully. I know I had a pretty good holiday, and I'm ready to get started coding again. The things I want to do today, we're going to, of course, pick up where we left off with the TreeSitter NIF. Also I mentioned in my social media posts earlier, we're doing that, but we also might be releasing 1.0 of Hardhat, because I've been kind of working on the documentation and keeping up with updating dependencies in the background. We haven't been doing it on stream. So it's very, very close. There's one last thing I wanted to do before we release it as 1.0. And then I'll make a whole announcement. It'll be great. I appreciate all of you that came and watched me code that, and remember things that I had forgotten from 2 years ago, and get better at Elixir again, because I hadn't really written any Elixir up until I started this stream in quite a while. So I'm pretty happy about that. It was my way to get into streaming live code. So thank you for being along for the journey. Let's real quick look at what we've got for our agenda today. So last time we did tree edits, and the big thing there was that we didn't yet figure out what those edits actually mean, which is okay. I think that we might leave that up to the consumer of this library. So if they've used TreeSitter in some other context, or if they really understand how an editor is put together and they're using this inside an editor, then maybe they'll figure it out. I don't feel confident in understanding what the right things are there, but we know that if they supply the right things, this will work. So we tested that it goes all the way through, and we at least get some shared nodes between the two trees after edits. So now the one thing that we did, which you can see a little bit over here to the left, is we had separate functions for parsing the first time and for re-parsing, reusing a tree. So I think that what we will do is we'll unify those, because we left this as a to-do last time. And maybe we'll get to multi-language documents and see if we can't get an example that uses EEX. That would be really cool. So, yeah, and then we'll, if we have time, we will try to release Hardhat 1.0. But I do have a hard stop today at 5:30 Central. I need some time to upload the recording of this stream, as well as get ready, because there is a very exciting soccer game that I want to watch tonight. My hometown team, Sporting Kansas City, is facing Houston Dynamo in the semifinals of the Western Conference for MLS, and that's like 2 games away from the final. So that's the overall whole country final. So that's pretty exciting, and they've had quite an interesting season. So I want to make sure to get to that. All right, I'm gonna take a sip of coffee. Cold coffee. All right, so let's look at unifying this parse and re-parse function. And I see a lot of familiar names there. Say hi if you like. Welcome to the stream. Okay, so last time we had we had done, we had originally done this where it just takes the parser and the text to be parsed. But what I would like to do is make it so we always have the previous tree. That previous tree could be nil. So we know that thanks to Rustler, if you pass nil for an argument to in your NIF function that is, an option of something, then it'll come out as none. So we can take advantage of that in the NIF, and maybe we'll do that bottom up, so we make sure we have the interface right. Excuse me. And then we'll get rid of this one, and we will and then we'll make all of our our functions in parser. Like, for example, this one, we'll get rid of re-parse, right? And then we will make an optional argument on here that is the old tree. Okay, so let's look in here. Okay, so we need to actually go down even farther and change. So let's start by changing parse here, right? Okay, so this should take. Hi Isaac, thank you for your comments offline. I really appreciated that. And we'll say option of tree. Maybe we'll see if we can do it like that. What did we do here? Right. So we took. Right. Exactly. So we'll do something like this. But it will be. So we'll need to do some as ref there, and here. I need to make sure that the TreeSitter parser takes an option of a reference, and not. Yeah, let's look at that real quick. Make sure we have the type signatures there correct. Docs, TreeSitter. Okay. So parser parse takes option of a reference to a tree. That makes sense. So which I guess I could have looked at down here, right? So we are going to basically take this. Yeah, so this line, let's kind of take this line. Let's rename this old tree just to be consistent here. And what I want to do is, since this is an option, we can do old tree dot map t dot lock. And we don't need to say, we don't need to use the question mark operator there, because we just want to turn, and this is actually not map, this should be and then, or flat map, because when we get in here, this is the mutex, right? Or this is this object, which we deref automatically to the mutex. So we can say, if we actually have a reference to this tree, which is our tree struct, then we can call lock on it, and OK turns a result into an option. So and then would mean that that it's going to unlock and return the if it is able to lock it, it will return the tree inside a guard. I imagine the hello polymathic man. I imagine the type signature is not going to be happy here, because what we have is we have this is going to be option of a mutex guard at the end of this statement, which interestingly is okay here. Now we do the question mark, so that unwraps it to a mutex guard, and this borrow does the deref mute, or I'm sorry, the deref, the regular deref. So I wonder if I'm concerned that actually what's going to happen here is if I do this, because this would make it most similar to this part. If I do this, the compiler is probably going to tell me, hey, this reference gets dropped. I'm not positive yet, but let's just put it in there. The other option is that we explicitly call deref, possibly, in here. Why don't I leave this off and see what happens? Because I think that now there are going to be a bunch of other compiler errors, but I think if we do it like this, it's going to be able to coerce those references automatically. If it can't, then we're going to have to do something else. So let's mix compile. It's going to fail because it doesn't have the right. Okay. Fine. Right. So it's complaining it expected option of a reference tree and it got option mutex guard tree. Right. So that's kind of what I expected. Let's see if we can put a reference there and if it'll coerce it for us. Oh, yeah, okay. So that's not right either, because that created a reference to the option, not a reference to the inner part. So let's look at options methods and see if there's something, because like asref is fine if you're taking a reference to the thing. It'll return an option that contains the reference. We might be able to do that. Let's see. There might be, like, there's as deref. Right. Okay. So it converts an option of t into an option t of target. That's, I think, what we want. We want as deref, and I think I used that in the last stream. I just completely forgot about it. As deref. And then we'll ignore the other compiler errors for now. We just care about that one at the top. Right. Okay, so that gets us what we want. So let's get rid of this method. We don't need this anymore. It's the same thing. And then the old tree is optional on the end. Okay. We can go on up another layer. Let's get rid of this NIF function. We're not going to use that anymore. Remove it from the bindings down here. Parser re-parse. And then where's our parse function? So this is going to take the old tree, which is going to be option of resource arc parser tree. Right? And then we need to pass this note the signature. We can just pass this and see what the compiler says. It's going to be wrong. But the signature here, whoops, wrong one. There we go. Is option of a reference to this tree. So we probably need to do as deref again on the outside. Let's compile that and see what it complains about. Yeah, so try using as deref as we expected. Cool. I love it when those patterns are already codified and you just have to tell it the right thing. Okay, so this is one thing I expected. Returns a value referencing data owned by the current function, the temporary value created here. I think the problem here is that we are locking inside this, and so the scope of that lock is the closure, not the outer function. So we might need to do something in here, which is more like if let sum tree is old tree, then we'll say tree dot, and this is going to be excuse me, tree dot lock dot okay as deref, and then the else is going to be none, and then that might make this lock be part of the outer scope, so it won't be dropped until the end of the function, instead of that lock being, that mutex guard rather, I should be more clear, being dropped inside this closure. Let's give that a try. Yeah, so I'm still having temporary value freed there. Okay, I think what the answer is this, and put the as deref there, because then we're only turning it into the thing right when we're making that call. And here it's still like the type signature on this is going to be option of mutex guard. Yeah, let's try that. Okay, so I broke the NIF, but the NIF binding, but we are our Rust code compiled there. So we kind of worked through some borrow checker mutex stuff that was a little weird there, but I think we've got a good solution. And even though I prefer this sort of method chaining closure thing, partly because of my background with Elixir, but sometimes these more lexical constructs, the syntactical constructs rather than the functional constructs work out better, just in my experience with Rust. Sometimes, for example, a for loop is easier to understand than a chain of methods on an iterator. So, okay, so cool, we've got that. This is working. Let's go and fix the NIF. So we don't have parser re-parse, right? But we do have old tree as an argument here. So if we compile that, it should be fine now. Okay, so now we have a problem with our other module, which we need to go fix, which is not a problem. Okay, so what we're going to do here, and this is going to take, we'll say old tree nil is the option there, and then we're not going to have re-parse. We'll get rid of that. And let's see if we can compile that sucker now. Okay, cool. So I think we resolved that that particular issue. Good stuff. Okay, so we've unified that. I'm going to go ahead and make a commit there. Oh, Emacs being weird. By the way, if anybody knows how to contribute to Zed, I would love to get my org mode in Zed. That would make me so happy. Because so far, I started using it this past summer. So far, it's just been a superior experience in general. And I don't like tweaking my Emacs config that much. So even though I've been using Emacs since like 2008 or 2009. Doesn't matter. Okay, so we've got that done. Let's make a commit, like I said. We'll look at the diff here. Right. Okay, so we'll add that. We are going to say unify parse and re-parse into the same function method. Okay. And push that. Cool. And I don't know why I have 2 tabs up here. We only need 1 right now. Okay. So multi-language documents. We're going to need a couple of things here. So first, we're going to need to be able to switch the language on the parser, like set language, right? And because and I don't have the examples up right now. Let's pull that up real quick. Sitter.github.io. So down here, multi-language documents. It relies on setting the included ranges. So we'll find that method in the docs, and we'll use that. And what we might do, let's make a manual one first, before we consider any higher level tweaks. Any like bigger abstractions than just calling these functions, right? But remember last time I talked through this, the idea is you create a parser, you set the main language on it. In our case, it'd be TreeSitter embedded template, which we already include, but we just have to turn it on as a feature. And then we will do, and then you parse the original document, and then you iterate through the nodes. And if the node type is content, which we have, we have this pre-walk thing that we'll make use of. Then you collect the ranges of that, and you say if it's content, then it's then that is like HTML, for example, or if it's not content, then it's a template node, and you need the first child of it, the first named child, which would be the syntax tree of the contents of that template tag. And then you say that those ranges belong to whatever that embedded language is in their example. It's Ruby, for our example, it's probably going to be Elixir. And then you reuse the parser. Makes me wonder actually what the parser contains. Probably not very much, if you're able to reuse it this way. And then you set the language to the templated language. So in this case, HTML. You set the ranges based on the ranges of the nodes from the parent parse, and then you parse it as HTML, and you get a new tree. And then you go back to the parser and say, set it to the embedded language, and then you parse it with the ranges of the nodes that were inside the template, and you parse it in that other language. So we need to do 2 things here. First, we need to be able to set the language, and we need to be able to set the included ranges. And so let's get started on that. And we might just do it bottom up like we've been doing. So let's look at parser, and we can set language. So this returns a result. Okay. Yeah, we probably don't need to be that concerned about that right now. Okay, so if we go down here to parser, let's make a new function here. Set language. And and this is going to be TreeSitter language. And this is going to be, we'll do result self, and that returns a language error, just like the first one did, because we're doing this here, right? Yep. So maybe there's some duplication there we might consider removing later. I'm more concerned with making a good API for the Elixir side right now. So this is going to take self, right? So we'll do this jazz again. And we may want to we need to look at what we're doing for errors in here, because I don't think that we were. Yeah, I think what I need to do is possibly. Oh, we already did poison error. That's the only error that can happen from a mutex, from trying to lock a mutex. So maybe this needs to not be TreeSitter language error, but this needs to be Rustler error. Right? So we'll say we need to call, oops, I need to see this file. We need to call into NIF error on it. And I think that's, we use with NIF error. Yes. Yeah. Okay, so we'll do self.lock.with NIF error. And I remember we did those things. I was like, what are we doing those things for? Well, this is why. Okay, and then we'll say parser dot. Okay, so this takes a TreeSitter language, but we also have our crate language, and yeah, I think we should look at whether we want to do that here. Yeah, so we did this in parser new. We do this separately, right? So maybe that's what we'll do here, and yeah, let's do that. And then we don't worry about that here. It's actually a TreeSitter language at this point. That's probably better. And not question mark, we'll do with NIF error. I don't like doing that everywhere, but that's what we got. And this doesn't return result self. This returns that, the empty tuple, because we're just mutating this. We don't care about, this doesn't return a new parser, right? This just sets the language on the current parser. Okay. So we need to do something similar for set included ranges. And we'll do self. And let's look at that API in here. Set included ranges. So this takes a reference to a slice of ranges. And I believe we have, in this file, we have range. And we're able to convert it into TreeSitter ranges. So, I'm sorry, it's bijective there. We can do it both directions. Okay, so here we want something like let's see, ranges. Yeah. Ranges is going to take, let's just say it's a slice of TreeSitter ranges. And that returns a result of included ranges error. So we probably need to do this. We probably need to impl into NIF error with this. I imagine it's simple, but we'll see. Okay. So let's just copy that. And this is TreeSitter included ranges error. And we'll do this. Although, again, this probably needs to be Rustler error, right? And we do parser set included ranges. Do you need your error type to be from the Rustler crate? If you can use your own error type, then you can implement it from. Yeah. The main thing that I'm trying to do there, Leaf, is it's a good question. Is I want this type because if your NIF function returns a result where the error branch is, or the error type is this type, then it'll get turned into a tuple that says error and the thing, where that thing is always, something that can be turned into an underlying term. In our case, it's a string. So that's why I'm doing all this goop with NIF error. And I really don't actually like it down here. But you make an excellent point that I could, use something like this error and turn all these things into my crate error, and then turn that into the NIF type. Maybe that's something we can do as a cleanup in a future thing. So let's do this. Okay. And this is with NIF error. Yeah, because it does kind of clutter it, doesn't it? And if we just use the question mark operator, it'd be a lot cleaner without these extra things. So you make an excellent point there. All right. This is not going to work. Let's try to compile it and see where the compiler says we're wrong. Okay. So yeah, we're not... that's not available because we don't, with NIF error found for enum result in the current. So okay. Yeah, I mean, this goop. Oh, okay. So actually, this may be a reason to go ahead and do what you were suggesting, Leaf. We don't, I can just use create error star and get around that. That's like a trait thing. The trait isn't in scope. And now it's going to complain about in trait bounds. Yeah. Right. So in this case, we actually need to do the thing that we did in the other file for TreeSitter included ranges error. Because we couldn't define it generically, because then if our error type has generics in it, then it doesn't work. The compiler is not that smart. That's why we have this, and then we have these explicit, if I recall correctly. And I'm just going to do TreeSitter as a thing there. And that may satisfy that for now. Okay, so now it's just saying these are never used, which is fine. So we got around that by including the trait into that the imports on that file. Yeah, and I'm not especially happy about this. The problem here is that the lock statement returns a poison error potentially, and the set language returns the TreeSitter error. Um, so I don't know a way around that without making our own error type. But that might be a nice thing to clean up. So let's go ahead and put that in our to-dos. Clean up error handling. We'll do like make our own error enum for each error type. And then we'll impl into NIF error only for our custom enum. That way we can keep this a little bit cleaner, and it can be our own error type, and we don't have to like bother with calling with NIF error everywhere. Also, the this error crate is really fantastic. If you haven't used it, highly recommend. Okay, so okay, let's go up a level. So we need to make some NIF functions here. And I don't, because these are just switching things on here, I don't actually think they need to be on dirty CPU schedule. Note that when we created a new parser, we didn't put it on the dirty CPU because it's not actually doing that much work. So we can probably do that for these as well. Just do plain NIFs. Let's say parser set language. And it's going to take our language enum, and this, here's that NIF result thing, and this is going to be that, and we'll do this. We're going to say parser, or no, this takes the parser, right? So we need this argument basically. And we'll say parser dot set language lang impl. And I think since that, yeah, I think that returns the correct type. Okay, and then let's look real quick. Yeah, so this is basically NIF result of the empty tuple, the unit. Okay, which I could potentially switch that around, but I'm not going to bother. And we do something similar for set included ranges, but what we're gonna do is we're gonna take our range and map over that slice. So I don't know. Let's just give it a try. Parser set ranges, and this is going to take our parser again, and this is going to take ranges is going to be a slice. Here's the thing that I'm not sure about, but we'll find out when we compile it. I don't think there's anywhere else that we're taking slices in our NIF functions. Like, we take binary as a as an Erlang term. We might have to look at that, but let's power on. Continue on. Okay, so this is going to be this is a document range, because that we defined it in that module. Okay, so let's do map this. So ranges dot do iter map, and this is going to be, let's do collect into TreeSitter range. Into collect, and then we'll do parser.set ranges. Set, what is it? That's not the right. Set included ranges. That's what I want. Let's rename that so that we're consistent. And that's going to take ranges. Okay. And I think that's probably correct. We could do from in here, whatever. It doesn't actually matter. Let's add those. So we have parser parse, parser set language, and parser set included ranges. And let's find out how wrong we are. Yeah, okay. Interesting. Okay, so that is not copy, clearly. What we could do, I think which is appropriate here, rather than this being a slice, if we do this as a vec, then it'll be owned. Yeah. Okay. So that corrected the problem, because here it was assuming it was a borrowed slice, and whatever magic that Rustler does to try to fix this function up so that it actually can convert between the beam types and our types, like having it be a slice meant that the contents here inside this iterator were going to be references. So if we just say it's a vec, then we own it, and we don't have to care about converting from references into new things. So I hope that made sense. Cool. And let's go back up to our NIF, and we need to define some new functions. So parser set language takes a parser and a language. At some point, I'll probably write a def-nif macro just so I don't have to type this so many times. That would be nice. Maybe I'll send a pull request to Rustler adding that def-nif. Okay, and set included ranges. Parser ranges. Okay. And that needs the that. Compile that, and the binding is connected. Okay, so now we can go up to the parser.ex, and we can say set language, and what we need to do is take this, match on that, and this is the new language, and then we'll do something similar to this, right? So we're gonna, let's just start with that, and it's gonna be parser set language, parser, and new language, and we don't actually need the old language. So I'll make this a little bit cleaner. And if we get an error, right, then we return the error. And if we get anything else, it'll actually be nil, probably. We'll just return OK. And yeah, this only contains parser and language, so we'll make a new one of those. The reason I'm doing this is so that if you like poked at the struct, this parser inside a parser is the actual reference to the Rust struct, and then the language we're just keeping around here. And I think it was because then, what was it? Oh, right. So if we have the language in the parser and we call parse, we can attach that language atom to the tree that was output, so you can see what language that tree was in. And then if it's doing any other things with the tree and that language is needed, then it's in that output as well. Okay. So pretty simple boilerplate stuff here. The reason I'm not matching on this is because we know it's going to be unit, or in other words, nil. We don't care. If it succeeded, we get the thing. If it didn't, we get error. Okay. Then the other cool thing about this is this will now. This does not lend itself to piping, partly because these things can fail. There is, I would say, a small chance that this would actually fail based on how we structured the library. We could change it to ignore failures, but and just return the thing, or raise an exception instead. Then we can have something a little bit more fluent. But I think this is okay for now. Isaac says, don't know if it was applicable in this case, but I find myself using copied more than I'm comfortable. Yeah. Remember, though, that copied only works on types that implement the copy trait. So if you have an iterator over where the items are something that implements copy, then you can do copied on that iterator. In our case, those don't implement copy, and I think there's probably not a strong reason to make this implement copy, even though this is not a big struct. This is 2 U sizes, and the point I think is 2 U sizes, right? So you're talking about 6 registers. Maybe it's okay to derive copy on this. I don't really feel it's necessary in this case. Cool. That is an excellent point, though. I use copied a lot as well. But in the case of this being a NIF, and like Rustler is doing some stuff with the syntax tree of our NIF code to create converters. So like it's taking whatever it's getting from the beam and trying to convert it into this type using the encoder and decoder traits, right? As well as what we're returning, it's trying to encode it into a type that'll work for the beam. So there's some magic down in those macros, those attribute macros that I haven't really dug into yet. But it was just easier to do vec instead of a slice. But I do find myself using copied as well on iterators a lot. Okay, so let's look back up here. So we got set language. Let's go ahead and do, and this is going to look really similar, so I'm just going to copy pasta. Let's do set included ranges. And we're going to say ranges, and we'll put a guard on this when is list ranges. We could also do something like pattern match. I think the guard is probably fine. We could also potentially loop over this set of ranges and make sure that they're all the range struct and raise an argument error. And this, actually, we don't care. It's not changing the parser, right? It's just setting an internal property. So just return OK if it works. How do we feel about that? Let's look real quick at the Elixir docs. Is struct, right? Yeah, so we could do that pretty quickly. Terms true struct of name, otherwise returns false. You know, we could do like match as well. Hi, Colin. Nice to see you. Colin, not Colin. Welcome to the stream. Yeah, let's, just for argument's sake, let's do that. Let's say, ranges, and we'll say match question mark TreeSitter range 1 raise argument error. Excuse me. Must be of type, must be TreeSitter range structs. I don't know that that's correct. Let's look at raise, and I think that, right, okay, that's fine. An argument error is the correct thing to do here, because if you're passing the wrong stuff and we're not pattern matching it, there's no way to pattern match across that whole list. This is acceptable, I think. Yes, Colin, we are working on TreeSitter for Elixir, so we're fairly far into it, and we don't, you know, support pluggability of languages. We have a set list at first, but yeah, we're going top to bottom and back and forth. So we've got the NIF written in Rust, and we are using Rustler, and we are exposing the API here in Elixir. Isaac asks, doesn't Rustler have to do something similar in the dyne to static type mapping? Yes. But if we're going to call into that, I kind of would rather control the error in this case. And maybe I don't need this in there, but let's say all given ranges must be TreeSitter range structs. Okay, so this is wrong. Nested captures are not allowed. That's what I want. There we go. Cool. Okay. So that's pretty good. So now, in order to adequately test this, which we hadn't tested this other thing yet, in fact, our TreeSitter test might be broken. Yeah, so this is using re-parse, isn't it? And I think what we need to do is just change that. There we go. And this is going to be, takes the tree last. Yeah. Oh, yeah, that's a good point, Isaac. I hope it will return better, or at least more useful errors. Sometimes those, Like I don't know if you remember in a previous stream where if you passed an atom as the language specifier. Um, let me get back to the Elixir code here. So if you try to create a parser with a language that we didn't support, not even didn't support, but didn't specify in our custom enum, um, it would have some weird like Rustler error. So we could do something like um, have a check up in here that checks for supported languages. It kind of does double duty as that conversion does, but it might have a friendlier error. So that is something we might want to do in the future. Okay, so in order to get this, I mentioned before, we're not. Um, I think I want to actually make this. Let's run mixed test. I think this is broken. Yeah, we've got a def. What have we got? Argument error. It's there. Oh, we did that wrong. I'm glad I ran that test. Okay, so here, um, yeah, we need to not pass the entire Elixir struct. We need to pass the tree that's inside this. So I was doing that wrong. So if is nil old tree, and then we're just gonna rebind it here. And actually this is it's good that I looked at that and ran the tests. Is struct term name. Okay. So old TreeSitter dot tree. Then we know that we can do old tree dot tree, and that'll give us the reference. Otherwise, it's nil. And actually, the return value of an if is nil unless you do that. So and then we should be able to pass the right argument there. Yeah, that was the problem. Um, okay, so I think we committed that. Yeah, so I want to add. This is where I wish I had maggot. Let's add test because we know that change. Lib TreeSitter parser, right? Okay. We're going to patch. One. It's okay. We don't have to have a clean Git history here. Oh, what is it? That's a good question. What is the name of the doc browser tool? Is it Mac only? Yeah, this is a Dash. I've been using it for many years now. It's pretty good. There is an analog for Linux, and I've forgotten what it's called. But The main thing is that it defines a file type, which is basically an SQLite database, that you can use in any of those programs. So yeah, this is Capelli Dash. And I'm kind of addicted to it, even though they keep changing the interface. It's very useful. It's quick. It does not, unfortunately, pull documents from docs.rs, which is my main complaint about it right now. But so like you can't go in here and oh wait, is this new? Oh my goodness, this is a game changer. I didn't notice this. Thanks for bringing it up, Isaac. Here, let's add TreeSitter. Yeah, let's do that. And then I won't have to go to the browser. And what are some other things that I use? Nom, for example. Well, let's do WASM bindgen because that's work stuff. And JSSys. And WASM bindgen futures. Oh man, I'm like, this is Christmas for me. This is why it pays to upgrade, I guess. And what are some of the others that I use at work? That'll do for now. Okay, so we have TreeSitter, and we should be able to search it now. That's excellent. Hey, yeah. Oh, I'm sorry. I believe there is something for Windows that is very, very similar. So yeah, okay, cool. This is what I love to see. I find this much more browsable than the sidebar on docs.rs. Okay. Cool. Yeah, I was going to patch this, but I think that we'll just make a commit when we're done with the tests. We'll say, hey, we fixed this piece too. So, what we want to do first is, I think here we defined Elixir as the default, but for test mode, and I don't know if this is the correct way to do this anymore. I want to do we want embedded template, and we want HTML, and then we can do a test similar to the the example that they give, right? Okay. Let me make sure that that's going to compile. Yeah, so now it's pulling in those other things. You can see it's changed the what it's compiling in. So we should be able to in our test. Parsers simple mod. Okay, gets the root node of the tree, gets all. Okay, so we're gonna say supports multi-language. Documents. Okay, so let's make a document, and we'll use this, and we'll say HTML, and I don't know, body. And then we'll say title like this. So it sort of looks like in EEX template, right? And this will be H1. And then we'll say P equals body. just to get a simple example, hopefully simple enough, that we can parse. And we can start to use this API we've created. Okay, so our game plan should be that what we see, we parse with embedded template first, right? And we'll see a node that goes to here. And then we'll see a node, and then we'll see this template node, and its child is that, right? It might include the equals. I don't actually know how that works, but I think that it has a named child. And the equals probably doesn't matter in this case. It probably just parses this. And then we have a third node, which is this amount of text. And then we have another template node, and so forth. And then we have the final, the fifth node. So what we want to get is yeah. We'll look into Windows. It looks Google always has a hard time recommending the official docs. Yeah, I know that feeling. I hope you're able to find something that works. Okay, so let's make a parser. New, and this is going to be embedded template, right? And then we're going to say, so let's get the template tree is going to be parse, and we're going to pass the parser, and we'll pass the document. And now we want to walk, and I think it might be worth looking at what the nodes look like in the embedded template. So maybe what we'll do is we'll just we'll start by inspecting the output of pre-walking the tree, and then we'll get an idea of, let's say, template tree, put a label on it, and we'll get an idea of what the nodes in this tree look like. I think it's just like content are the things, like it showed in that example. Content are the things outside the template tags, and there's going to be a template tag. And I think the challenge here is that we haven't exposed in the Elixir API yet a direct way to go give me a child node of this node. We haven't exposed that yet, and it's not trivial. So the compromise was, let's make something that lets you walk the tree and produce all the nodes in a prefix order. So in this case, what I want to see is like, what's the contents of this? I expect there to be, I think it was like there's 5 nodes at this level. So including the content and the template tags, there's absolutely going to be a root node, right? And then there's going to be child nodes of these template nodes, and that's the part I'm curious about. What do those look like? Okay, so let's run this test. Test TreeSitter test, and we want line 91. Okay. And I actually need to do this correctly. So assert, right? And we'll do assert. Okay. Template tree. Okay. Now let's look at that. Okay, so this range is exactly what we want to pull out when we pass to set the included ranges. So this is a content node. Interesting. So remember, we are not returning named nodes. We're returning all nodes. So I think that we need to probably look at. Okay, so what we want is the code node, right? Note that this was a close of a template tag that came right before the or right after a code node, and here's the open of that template tag. So I think that that's what we want to do. So what we'll do is we'll split and filter these into code nodes and content nodes. I think that's the way to go. Yeah, because we don't care. So this output directive, note that it comes right before this concrete node kind, which is this. So this is a concrete syntax node, whereas the code one is an abstract syntax node or a named node. And the parents will come before the children. So in this case, output directive, percent equals inside there. That makes sense. And content is more, and we're not including the text here because we didn't pass it through when we did the walk. That's fine. We just need to know the ranges for this. And again, here's code inside a template tag. And output directive, and we got the opening one. And then there's content node before that. And then template is the root node. Okay, so I think that makes it straightforward to understand, for me at least. Hopefully y'all are following along. Okay, so let's do. We're gonna take the temp. Let's get. Okay, so these are going to be HTML nodes and Elixir nodes. And let's do ranges, right? Ranges. And we want to take the template tree, and we want to do TreeSitter.tree.prewalk. And then we want to kind of split and filter. Let's do this slightly differently. Do this as a for loop. So let's go for node comes from this, and let's actually just ranges, and let's put this back. Elixir ranges. And it's there. What is the for syntax here? We want the one that has an accumulator expression. Into and unique. No. Into relies on collectible, and we're not doing collectible here. Okay, so here's the reduce. So we can reduce into, our tuple. We take the accumulator, and we return the accumulator. Okay, so let's do accumulator is two empty lists in a tuple. or was it reduce? It was reduce. And this is going to be HTML ranges, Elixir ranges. Okay, so we're going to do case node dot kind, and if it's a content, we want to go node.range onto HTML ranges, and then Elixir ranges, right? And if it's code, then we do the opposite. We continue with this, Elixir ranges, and we need to concat that on the front. And I don't think it matters. We'll have to see. We'll see if this works. But it, obviously, if it's anything else, we just return the original. Okay. Yep. Okay, and now let's see if we get these correct. Okay, I'm going to run this. I think that this should be easy to. Here, let's do it like HTML, like this, and then we'll get Elixir. It'll be a map instead of a tuple in this case. We don't need it in here. I don't actually think that. I mean, we could do it as a map in there, but it doesn't really matter that much. Let's run that test again. Okay, so HTML, we got 3 ranges, and note they're in reverse order. So we could potentially invert them or reverse it at the end. I don't know that that matters that much. What I mean is, I don't know that it matters to the TreeSitter API. It might. And then we got what we expected. We got 3 ranges. So before the first template node, in between the 2 template nodes, and then after the second template node for the HTML ranges, and we got the insides of the 2 template nodes for the Elixir ranges. And again, you can see they're both of them are backwards because that's how cons works. Cool. Okay. So now let's get I think it's okay. TreeSitter parser set language. Let's set it to HTML. I think that's how we did it. I'm gonna get this way over to the left. I think all of our Elixir stuff is over to the left. Yeah, so if we got set language, oh no, it does return a new parser, right? So, and it's not, we have to do this, right? Because we're changing it. Okay, now that's not changing the underlying reference, but that is changing the contents of that struct that we have wrapping it. And that's an HTML parser. Bozo. Okay. And now let's do HTML tree. And here we need to do this is HTML parser, right? And then let's look at those nodes. That should be interesting. TreeSitter.tree.prewalk. Nodes. Okay. We are learning. We are growing. Okay. Cool. So we're getting a lot of, HTML nodes there, as we would expect. We are not, of course, getting the contents of that, but I think based on that, it looks reasonable. Yeah. So, note end tag, its children are open bracket slash, and then the tag name, which we don't have the text of, and then close. So, yeah, cool. Easy peasy. Okay, and then let's go. The only thing that is potentially bugging me about this API is we are reusing a parser. But this particular thing is not invalidated. So like, even if we make this new Elixir parser, we could still refer to this, but it has changed into Elixir mode. There's no way to say this has been consumed. We've changed that, so it's no longer valid in the old style. That is something to think about. And maybe what we do, and I know they're saying like multi-language documents, yada yada, try to reuse these things. That may not be a good idea for the Elixir API because of the semantics of everything is copied. But these references, they're just like from the perspective of the person writing the Elixir code, they're just opaque identifiers around some memory location inside the beam. And this may have been a bad direction to go because the semantics don't match up. You could potentially like reuse this HTML parser and go, hey, let's try parsing Elixir, and it actually won't work. Which maybe that's okay, because we would say if it doesn't parse, you're just going to get one big error node in your tree. Yeah. Okay. But the main thing I want to do here is make sure that these all work. Elixir parser document. Now, the thing is, what we didn't do and what's wrong, we made a mistake. I did not set included ranges here. So let's do that. That was a mistake that I regret. Okay. Assert OK is TreeSitter parser dot set included ranges, HTML parser, and HTML ranges. That's the thing I really wanted to test here. And we'll change this to Elixir parser and Elixir ranges. Yeah, that output from our test looked correct, but we didn't have the contents of what's inside those tags. So we were probably getting the template tags as well, or we were getting error nodes, and it's not obvious to me. Oh yeah, so here's an error node because I didn't set the range. It's like, I don't know what this is. Row 3 from column 9 to column 16. Let's look. So row 3, column 9 to column 16. It's like, this is garbage as far as HTML is concerned. I guess that shows you that the parsers are really resilient, and they'll attempt to skip over errors. But if you are using it wrong, like we were, yeah. Okay. So then let's look at the Elixir nodes, right? Elixir tree. It's a good thing I looked at that. Let's do that here just for argument's sake. And we need to come up with, other than these things don't break, we need to come up with a reasonable assertion about the output of this based on our input. Yeah. One thing that we could do here, I will make some assertions about what are these ranges, like how many of them are there. That's a reasonable place to start, I think. Let's run that test again. Okay, so incorrect range by index 1. Well, that doesn't help. Let's do list reverse. Oh no, what is it? Is it just reverse? Enum reverse. Yeah. Okay, so if you, yeah, so it does care about the order. They have to be in order. So now it's complaining about that, and that is not parse. That should be set language, right? And we're going to have to do enum reverse here as well. So they come in order. Okay, so you can see here we are getting Elixir nodes. So we've got the @ node and the identifier. And the unary operator, I guess, is the, yeah, combining those two. Right? What is this? Arguments. Row 3, column 9 to 14. Identifier call. That's interesting. Okay. I can't say that these are correct. But you can see here that the source, which is the root node for the Elixir parser, starts at row 2, column 10, and ends at row 3, column 15, not necessarily inclusive. So that's when you can see here the unary operator. Yeah, I think the main thing here is to make sure that we're not getting Elixir nodes out of spaces that should have been the HTML nodes, and so forth. So let's say we know that there's going to be 3 HTML ranges, and there's going to be 2 Elixir ranges. Yep. Okay, I'm going to remove these in specs. And what else? What else can we assert here? Let's make an assertion about that first node. Of the Elixir, right? Because we know that it's only going to start here. I'm sorry, here, and it's going to end here. And what is the contents of that? A node, range. Okay. And so we're going to do this as a match. Pre-walk. Elixir tree. And we want the range start byte, end byte, start point, end point. So I want to say the start point. And I probably don't need all these additional matches on the struct types. We could match them as maps. But I'm going to do that anyway, and let's get it formatted. Let's do this as 2 steps, or multiple steps, right? Let's do this, and then we can say stuff like assert root node. We know it starts on line 2, so we can say root node dot range dot start point dot row, right? The row 2, note that that's actually 0 indexed, so row 2. And we'll say we know that it ends on row 3. Okay, yeah, we'll just, for now, we'll do that. Now we can do similar things here. So we could say, we know that, and can I rename that symbol? What? You don't need to install software to rename a symbol, for Pete's sake. No. Okay, so we'll call this Elixir root. And you know, we actually didn't need to pre-walk to get all of them. We could probably just do root node. That might be, yeah, I know, Colin. So, okay, so we know that the HTML begins on row 0. And we know that it ends on row 0, 1, 2, 3, 4, 5. All right, and let's test that assumption. And okay, so Elixir tree, I messed that up. HTML tree. Okay, so I actually, that is row 6, because there's a line return in there. Good to know. Yeah, because there's a line return at the end of this. It's not trimmed. Okay, I think that's a pretty good demonstration of this. I don't know that I want to go any deeper into looking at what the actual nodes are. We just know that, you know, this shows the 0 row 6 here shows that this overlaps with this language, and we've kind of demonstrated the functionality. I think that's a good place to leave it for now. Let's look at our checklist here. Okay, so we can switch the language on the parser, and we can set ranges, included ranges. Cool. All right, let's make a commit. And let's look at what we're committing. Okay. So in test, we are enabling these other 2 so that we can test them. We can test the switching languages. We've added the NIF functions in our NIF module. we are fixing this error we had with parse, right? Um, and we support setting the language and checking the ranges. One thing we should probably do is check this particular issue. So like put some garbage in there and make sure that it raises an argument error. We can do that real quick. And then we've got the NIF. Okay, so let's make a quick test for that. Raises argument error when setting passing invalid ranges to set included ranges. So assert raises, and I'm going to have to look this one up because I always forget how to do it. Assert raise, not even assert raises. Okay, so it takes an exception name and a function, and we can give a message if we want to. I don't actually care about that, so we're going to take argument error. And let's get some of this scoop going here. Let's just do this before we pass that. Okay, and then we're going to say TreeSitter.parser set included ranges. And we're passing the parser, and we're pass a list of bogus. And that should be good enough to test. Okay, cool. And we're good there. Okay, so we're going to say support. Let's actually do a longer commit message here in the editor. So what we're doing here is we are fixing the parse. So this is mostly about support multi-language documents with set language, set included ranges. And then we also fixed a bug from the previous commit where the tree struct was not unpacked before passing to the NIF. A parser parse NIF. Okay. All right. And let's push that. And we've got about 20 minutes left. I think that's a good place to stop on TreeSitter for today. And next time we can look at cleaning up error handling as Leaf has suggested. I think it's a great idea. And yeah. And then we won't need that. We won't even need this trait at all. We'll just make it work. Okay. Okay. Or remove. Question mark. Okay. So I think we've got very little time left. I do want to stop at 5:30 Central. But I wanted to talk about what I've done in intervening weeks while we've been doing this NIF on stream. I haven't given up on Hardhat. But what I have done off stream is I filled out a lot of the documentation. So you see a commit from a couple days ago. I did the whole section on testing. So you can look at that. Like, you know, I actually, there are a lot of things in here. Of course, I've added some emoji in there, but I added the motivation section. I tweaked some of the language in other areas, including dealing with the fact that the last thing we did on this was we set it so that it's always merging the defaults with, or merging your customizations for particular middleware options into the defaults. And so in our examples, we didn't need to include all of the options, right? Because the defaults are going to include them. So in the examples where you're overriding the fuse options, for example, you only really need to set this one. The others are all the same as before. Okay, and let's see. I filled out the section about timelines, timeouts and deadlines. Sorry, conflated those two things. And talked about deadline propagation and testing. And testing was hard, I think, to write about because everybody wants to test differently. I just listed 3 things that I've used successfully in the past in them. If you have any comments on that, I would love for you to open issues on the repo. But the very last thing I started the other day, and what you'll see here is the diff is that, oh, and I didn't even do that right. What we want to do is support the latest OpenTelemetry Tesla library. So in the intervening time, since we've been doing the NIF, Brian Nagley, who helps administer that, that project, he's one of the committers. He tagged a release of this. There had been a bunch. I asked him, hey, can you release this? There had been a bunch of changes since like January of this year, but there hadn't been a release. So he was very nice to go in there, figure out how to do that, and tagged a release so we have a full like upgrade. And the big thing here is, so I was starting to do this. The big thing to note here is that we'll show it here in the documentation because this is up to date. Oof, that's big. So now it takes options. Before it did not. So you can pass an option that lets you override the span name. The main thing I wanted to do is have this propagator option, because when we did this our own way, we did this custom when I was at BlockFi, we had a propagate true or false, right? But what you can do is say propagator none, and it won't add trace headers. So this would be mostly useful for cases where you are calling a third-party API and you don't want to expose any of the details of your internal tracing to that API, which I think is a pretty common use case. So what I want to do with the 15 minutes now that are left is finish up making this change and document it. And then maybe we can tag 1.0 and just be, happy and move on, and make an announcement and celebrate. So that's what I would like to do with the remaining time. Okay, so where was I? Oh yeah, so I made this change here and I said doc false instead of doc false. Okay, so by default, we don't actually want to override anything here. We want to use the defaults that come with the middleware. So I don't know whether it's valuable to put anything in the defaults module here. But what we might do, just for the sake of consistency and future extendability is to do something like this. And I'm getting a little spacey because we've been doing so much Rust code. I've been talking for a while. Okay, so we'll define one. And I think what's important to know here is that we'll go ahead and put it in the defaults module, and we'll just have it return the empty list for now. Because I don't think that we need to override that by default. And we'll copy the documentation out of here. Basically, we'll take this and use that as our our defaults. That's not to say that we will have any different thing here, but we'll just be returning an empty list. But I think, you know, to duplicate the documentation there is not a problem. Okay. All right, thanks for coming, Isaac, and sleep well. Okay, so just to be consistent here, let's look at what the other documentation says. Okay, so not that. Default options for the blah, blah, blah. Okay. Default options for the open telemetry. And this should return an empty list because we need to merge that. Okay, so I'm going to paste all that. That's probably, yep. Okay. Let's make sure that this formats correctly. I like to wrap, even though, oops. We will make sure that this looks correct before we push it, commit and push, so don't worry about that. I'm just line wrapping for my own purposes. Okay. Okay. So this is what the options are. I think I need to maybe rewrite this because this is just a straight copy. Maybe I say the options include and then we'll put the default is not to override the span name. Or say the default is the default span name is chosen by the middleware. I don't know that that needs to be bolded, but we'll have a look at it. Right, and this is basically, yep. Now we could potentially include this field in our default ops. It's not necessary because the middleware itself does this. But yeah. Okay, the default is empty. I'll just say it's empty. Okay, so then at least we have documentation here about these, even though that's like basically does nothing. You know, we had to supply them for some of the other middlewares like the regulator, the retries, etc. Fuse. Even though they have some of their defaults in there, and these are basically unchanged from what the defaults are, but yeah, okay. So let's run mixed docs on that. And see what comes out. Okay, so yeah, that's I don't know that we should look that up, make sure that that's correct. Hotel propagator text map. Yeah, that's actually not a function. Oh, that's hilarious. Okay. Oh, it's actually open telemetry get text map injector. So I think if we fix that, um, open telemetry, right? So I think that that's right. This is the example that's correct. Okay, let's see if that. Okay, I think that corrects it. Let's open doc index.html and have a look see. Okay, so and then we will go and fix the README real quick. But let's look at that defaults. Open telemetry ops. Okay, so this will actually link to the correct correct function. That didn't get bolded, so I might just remove that. So let's remove the bold on there. Not necessary. And it could be just because I'm wrapping lines that it doesn't do that correctly. I don't know. Run that again. Oops. Yep. Okay. Cool. All right, we just have a few minutes So let's get that edited, the README, the section on telemetry. So going down here, okay. So we can remove this. Okay, maybe we can say remove this part. It will observe any path parameters you interpolate into the URL so that similar spans can be easily aggregated. To disable propagation, I want an example of, yeah, oops, or change other behavior of the tracing, override the open telemetry ops 0 function. And we'll do similar to like what we did down here. We'll say def module no propagation client. I know those names are dumb, but they really, I think it helps to give a dumb name that is immediately identifiable for what it's doing. Disable trace propagation for talking to a third-party API, something like that. And then the other thing we could say here is for more information about the options available to tracing, see hardhat.defaults.openTelemetryOps. Or Tesla.middleware.openTelemetry. Okay. I feel that's pretty good. Pretty good place to stop too. We're almost at 5:30. Look at the diff real quick. Yep. Got the new section in the README. Got the OpenTelemetry ops. Got the defaults, which are empty. And off we go. So this is going to be support OpenTelemetry Tesla. New options on OpenTelemetry Tesla. Okay. Mixed tests. It's one of those days, isn't it? Okay. So the only other thing that I might do and amend it to that commit is in here. Make a no propagation client like we did in the open telemetry ops and put propagator alligator none, propagator none, and then we can do start supervised no propagation client. And we can go down here. Okay, so this is records, spans for simple requests, records, spans for parameterized requests. We don't actually care about receiving the spans, but what we do care about is does not propagate trace when disabled. And we'll do bypass. And we'll do bypass expect once. Con. And we want to do look at plug con real quick. Headers. So like a get header, get request header. Okay, so we'll say assert equals plug.con.get request header. Oops. Right? This is takes the con and trace parent because this is what it would use to propagate. And then we'll do, we'll do this. And something like so, except this is going to be no propagation client, right? And we don't actually care about that, any of that goop. Okay. And yeah, I think that will do it. Let's run that test. Boom, I blew up. What did I do wrong? Okay. So that's actually not correct. So we did get a header. I wonder if we can do assert, like defer this assertion. The other thing that we could do is send it to the test process and assert it here. That might be better. Then it won't crash this. So parent self, and we'll send self or send parent. Say trace header. And then we can do assert receive, trace header, empty list. Similar to how we did here. Let's put 1,000 on that. Okay, so it had a trace header. And I think that there's something wrong here with either this. Note that it's not crashing again on that bypass thing. And it probably called it more than once because when bypass crashed, our client automatically retried. So this is the better way to do it. The How can we here? Let's just, for argument's sake, clean. Make sure we have our deps updated. Compile everything, test again. I think we're fine. We just need to make sure that that test can pass. All right, what do those docs say? Real quick, and I need to finish up because we are running over. Propagator, none. Let's look at the code and make sure it actually does that, because I have a doubt now. Okay. So, right. So it says if propagator is in there, then, or default to get text map injector. Maybe propagate none should do nothing. So I'm either propagator, telemetry. Okay, there was a bug. Let's run it now. It should pass. I think it helps if you don't typo the name of the function you're trying to override. Okay, so that's good. And let's amend that. Okay, so I feel pretty good about that. Let's push. And we're gonna bump 1.0. Woohoo! And I'm not going to do it right now, but I will formulate a release announcement and put it on all the channels I can think of. So we're moving forward. Okay, we're not using recon in our testing anymore, so we can remove that, clean that up. All right. And real quick, I'm going to check that there are no open Dependabot. Nope, nothing on Dependabot open. So we're in good shape. You know, look at all these docs. Holy cow. Like, I feel like I would be really, really happy if I were going to adopt something new and see all this documentation for it. You know, even thinking about the things that really aren't the problem of the library, like how do you test your clients? I think that's nice to have in there. Okay. So there is a problem here. Or not. Maybe not. Never mind. Let's bump that to 2.3 because we're using that option. Even though the mix lock, let's do that. I feel more comfortable with that. Yep. Yeah, I don't see anything else here that we need to fix. But being more specific on this, I think is useful, because if that gets updated, I want to be able to check that we are passing the correct options to it. So let's do this. Let's look at the diff real quick. Okay, we are going to do Release 1.0.0. Well, helps if I add. It's one of those days. Okay, so and we're gonna get tag v1.0.0, and let's push that and push tags. And I don't recall if we have in here a release. Yes, we do. So on any tag, this is going to do the hex PM release. So all I have to do is wait for that to finish. Let's look at the actions that are ongoing. Okay, so this is release. And let's watch that. Boom. It's there. Thank you all for joining me on the stream today. I think this is a good place to end it. And we'll see you next week. I do want to I'll send it out on social media accounts that I have. I do want to consider doing something new next week. We might do more TreeSitter. But you know, it's that time of year. Maybe we'll do some advent of code together. That might be fun. Let me know what you think. Otherwise, I will see you next weekend. Thanks everyone who came. Nice to see some new faces.